We're finishing up this 1.1 note sheets today. We're finishing up the note sheets today. So I feel like we did finish this up yesterday. So what we're starting on is writing these types of equations and information into set builder notation. Now, set builder notation, we've gone over. It's a way to describe groups of numbers without either having to write it out or forming a set pattern. Now, if it's feasible to actually write it out or get a pattern, we can do that. Because integers, the set of all integers greater than 5, we could do that 5, 6, 7, 8, 9, 10, comma, dot, 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 dot. But for here, we're going to write it in set builder notation. Now, the two main pieces we need for set builder notation is the type of numbers we're looking at. What is the group of numbers we're talking about? So for us here, we're talking about the set of all integers. So our type numbers are going to be integers. The other part we need is the description, greater than 5. So we're talking about the set of all integers greater than 5. The numbers we're looking at are integers. Our description is saying that they're bigger than 5. So those are the two main pieces we need. In set builder notation, when we have the description, especially so for greater than 5, we need to write it as an inequality. Anytime we talk about variables, we normally use x. Because x, for us in mathematics and most of the natural science field, represents or is a unknown. It's something we don't know. Okay? That's actually why they call it an X-ray. It's an unknown. We're looking at an unknown. The X in X-ray stands for unknown. But what are we saying that it has to be? Greater than 5. So X is greater than 5. We have the description. So now we have everything we need to set up set builder notation. So when we do that, we start set builder notation with our breaks. X. Now, if it was the real numbers, we could go bar, because brace x bar, the set of all real numbers x, such that, give our description. But here, are we talking about the real numbers? Integers. So we can say x is an element of the integers. X is an integer for all x in the integers, such that, what? X is greater than 5. X is an element of the integer such that x is greater than 5. That's it. Questions on this here? Now, this isn't the only way we could write this. We can write it in many different forms. Now, big ideas, the textbook starts it off here. The set of all real numbers x, such that. And they set every one of theirs like this. Set of all real numbers x, such that what? We have to say that x is an integer. And x is greater than 5. That is not my favorite way to write this one out, because that's a whole lot of writing to say the exact same thing we just said above it. Those two set builder notations are the exact same thing. If I had a choice, I'd rather do the one above it than that one. Would you all agree? If we wanted to, we could simplify it a little bit. We could say the set of all real numbers x such that x is the element of the integers and x is greater than 5, because it's just, we simplified that. X is an element of the integers, x is an integer. We condense it down. All three of those are saying the exact same thing. I don't need all three. We just need one. Because if all three are saying the same, we can just need to list one of them. But I'm listing more than one to show you that there is more than one way to write this. And again, it's most of the time when we write this, or especially mathematics, in proofs, there is a set form that they use, and once they use it throughout the rest of it. questions for this here? We feel good with the first one? Yes? All right. We ready to look at B? We have from negative infinity to negative 1 or from negative 1 to infinity. Did they tell us what set of numbers that we're looking at? Not directly, not like the first one where they said the set of integers, but they gave us an interval. Anytime we're looking at intervals, we're saying all the numbers between those spots, which means we're talking about all the real numbers, because everything between those two. Whenever they give us an interval, we automatically know we're talking about the real numbers, all the real numbers between those spots. Now, it'd be very nice if we could just say brace x bar parentheses negative infinity comma negative 1 parentheses or and just fill it in. We can't. We have to have it as an inequality. Now, if they gave it to us as an inequality to start with, we don't have to do anything to it. We can just throw it straight into set builder notation because that's what we need it as. So the first thing we need to do is rewrite each one of these as an inequality. Now, both of these are going to be unbounded because we have one endpoint. For the first one, it is negative 1, yes? And it's going which direction? Positive or negative infinity? Negative infinity. So we're talking about all the values of x, any value of x that is what? Less than negative 1. Because x is just saying what values of x, what numbers will satisfy this are contained within that set. And for us, it's all the values of x less than negative 1, yes? Could it be equal to negative 1? No, because what do we have next to the negative 1? We have a parenthesis, that parenthesis. Because if it's a bracket, it's included. Parenthesis says it's not. Since it's a parenthesis next to negative 1, it's not included. So it's just less than. Questions on our negative infinity to negative 1? Let's look at negative 1 to infinity. For here, because when we write it as an inequality, we will have the variable x. And we're going from negative 1 to infinity. So we're saying that the numbers have to be what? Greater than. We good? Yeah. Questions on our two inequalities? Now, the word we're going to have to put between it because we will need, because we started out with or before, we still have or, because it's this one or this one. Either x is less than negative 1 or x is greater than negative 1. It's one of our two statements. Questions on how we turn this into an inequality, or how we turn these expressions into inequalities? We're good? Now we need to write our set builder notation. So we have our type of numbers, all real numbers x. Yes, so brace x bar. I'm going to put it right in front of our statements because that's what we're going to put in the description, yes? So might as well put the first half in front of it, and the only other thing we need is what? The brace at the end. Questions on this here? Now, we don't have to graph it. Now, for some, it might be nice to graph it because sometimes seeing it graphically will help us see the inequality, how we write it. For the left one, our one main point is negative 1, yes? And we're saying we're going from negative 1 to negative infinity. So negative 1 would be open, and we're going to shade everything to the left, yes? Okay. So that's our first half. Or negative 1 to infinity. Well, we already have negative 1 up there, yes? So that means we also have to shade everything to the right. So we pretty much shaded everything on that number line except what? Negative 1. So for us here, really, it could be any number except negative 1, correct? So wait, we could have said what? All real numbers of x such that x is not equal to what? -1. For all real values of x such that x is not equal to -1. Those are saying the exact same things. One is just a little simpler than the other. And this only works because we had everything less than -1 and everything bigger than -1. We're able to simplify it down. There is no gap between the two statements. Again, either one of those is correct. You don't need both. You just need one of them. If you see the fact that the inequality statements for our intervals is everything but one number, we can use the second. If you don't see that, you write it just as we did the first way. That works too. Those are the same answer. I will take either one. Questions on this here? Let's look at number 6. Parentheses, -infinity, comma, -1, bracket, or parentheses 1, comma, infinity. So we have -infinity to -1, or 1 to infinity. So we do need to write these as intervals. These intervals as inequalities. So the first one, if we're looking at the number line, we're saying we have everything less than -1. So at -1, we're going all the way to the left, this way. But are we including -1? Yes. So that would be filled in. So our inequality would be that x is less than or equal to -1, because we include -1 in everything to the left. It's going to take me a bit to get back to the correct motions, because everything at -1 and to the left. Now our other statement. Here we're starting at 1 and going to the right. Is 1 included? No. So we're saying here that x is just greater than 1. Still need our or statement, because we're saying it's one or the other. One of them has to be true. Questions on this so far? So again, I will say if having that number line helps be able to write the inequalities, draw it. There's nothing wrong with doing that. If it doesn't help or you don't need it, that's fine. Don't do it. Now the only thing we have left to do is to do our set builder notation. Because we're talking about the set of all real numbers, we have our brace x bar, the set of all real numbers x, such that x is less than or equal to -1, or x is greater than 1. And then we finish it with a brace. That's it. Questions on this here? Questions on anything we've done so far? We ready for number 7? The set of all integers except -4. Okay. This time they specified what kind of numbers we have. We have integers. And the description is except -4. So we could have any integer but what? -4. So x cannot equal what? -4. So our description is just x is not equal to, or equal to with a line through it, -4. And here we can say x is an element of the integers, which is our z with an extra line. Questions on this here? We feel comfortable with these here. Probably a few, especially doing a few on your own, are going to help with this here. But again, after this chapter, we're not going to hit set builder notation ever again. I think it's good, especially for you to see it, know what it is, know how to read it. but we're not going to hit it again at this point. The last few that we have, we're going to pick between writing it out, listing the whole set, or set builder. Because if we look at the first one here, the set of whole numbers 50 through 54, what would be the first whole number in this set? 50, yes? Because since it says through, it is it's 50, yes? What's the next one? Then 52, then 53, and lastly, can we list them out? Is it feasible to do it? Yeah. 50, 51, 52, 53. So a problem like this here, it's feasible to actually just list the thing out. We don't have to do it in set builder notation. Because doing it in set builder notation and listing it out, one is not easier or harder than the other. Because if we did this in set builder notation, we'd have to start off with saying that for all x in the whole numbers, such that, then we're going to have to rewrite this as an inequality. Now our two endpoints are 50 and 54. X is indeed in the middle, and since it is equal to both, we're going to say 50 is less than or equal to x is less than or equal to 54. With the whole numbers, we can just count it out as fast, if not faster, than having to rewrite it as an inequality and then set it up. So on some of them, it's easier just to list it out. Especially if we have a pattern, 5 and 6 on the homework, we can just list it out and do the dot, dot, dot. Questions on A? B, the set of real numbers, 0 through 4. Unfortunately, this one we can't list out because, as we found out yesterday, the numbers that exist between 0 and 4 is a lot. We're not even going to try to tackle that. Trying to write out the numbers between 0 and 1 is an enormous task, or a Herculean task, let alone 0 to 4. This one would be one we would definitely want to write in set builder notation. Now we know we're going to start with brace x bar because we're talking about the set of all real numbers. Now we need our description. And we want the numbers 0 through 4. Isn't it just going to be exactly what we just did? Right, because it's going to be 0 is one of our endpoints, 4 is the other. And our numbers, our variable x is going to be between them. The values of x that we can plug in it, the numbers at work, have to go between these two. Since we're going 0 through 4, it would be 0 is less than or equal to x is less than or equal to 4. Questions on this here? Because real numbers, we're going to have to really default back to this if we really want to list them all out, because it's just not possible. We ready for the last one? I think it's one more, yes? Okay. The integers, negative 100 through 100. Integers we can list out, yes? Because the first one would be negative 100, yep. Next one would be, yeah, negative 99, yes? And then negative 98, then negative 97, then negative 96, then negative 95, and negative 94. Yes, I agree. We could do it. It is possible to do it. It would take a while to be able to do it. There's actually 201 numbers we would have to list out. I think that's a few too many. So this one, again, is going to be easier to do set builder. Because we can do brace x. X is an element of the integers such that for all real x, all real values of x in the integers, such that what? Negative 100 is less than or equal to x, less than or equal to 100. questions on this here? And that is it. So your homework is on page 7, that page right there, 5 through 14, 5 and 6. You can write it in set builder notation or write it out. Both of those you would set a pattern and give me dot, dot, dot if you're going to write it out. And then 7 through 14, I believe, says write each of these as an interval notation. So we're talking about the parentheses and brackets. So 5 through 14, yep. So 5 and 6, we can do that way. 7 through 14, we're talking about interval notations, our brackets, parentheses, our start and end points, or we're going to infinity, negative infinity. 17 through 20, you're going to graph. 17 through 24, so 17 through 20, you're specifically going to graph. 21 through 24, 26 and 27, you're writing it in set builder notation. So the full assignments 5 through 14, 17 through 24, 26, 27. Now, sometimes I will do even and odd, but I will specifically put it after the number set. So it'd be like 5 through 15 odd, comma, and then 17 through 24. Only the numbers that come before it would be the even or odd. Okay? So here, 5 through 14 all, 17 through 24 all, 26, 27. Yep.